Hello, I'm Peter Meldrum. I'm a Distillery Manager for SEM, and I'm just going to run through our I-DAF technology. So once you've done your bench tests, when you've done a site visit, and you've selected equipment, the I-DAF unit will be one of the pieces of equipment that will be utilised for the process. So stage one is simply the same as what you do in your bench test. You have 3 reaction tanks, 1, 2 and 3, for your addition of coagulation, pH adjustment and flocculation. Okay, so you've done your tests, you've established the pH, you set the pH on the control system. That then sends a signal to the chemical dosing pumps, so you know how much chemicals requires to be added. In the corner here we've got what they call the Polymer Mix Tank. So you've got raw polymer going in here, a water feed going in the top, a solenoid valve. It's basically mixed from a 0.5 to 1% volume to water. The polymer's purpose is the flocculation. It basically takes all the contaminants and binds them together and removes them at the end of the process. This is the control panel. You can see on the control panel here we have hand and auto. So the whole function that is you can actually operate the system on manually, but you want to run it in automation. So basically it reduces the amount of people required to run the system. So you have everything on the auto set up in auto. The system will not work until you've got the forward feed pump in the automated position. This is taking the suction from the dirty effluent tank into reaction tank number 1. Okay, so here we've got our chemical dosing pumps. We've got one which is the mixed polymer, one of which is the raw polymer, coagulant, acid and caustic. Mixed polymer is basically taking suction from the tank in the corner here and adding it into reaction tank number 3. The polymer is just taking raw polymer and adding it into the mixing tank. Coagulant is being added into reaction tank 1. The agitator in reaction tank number 1 runs at a high speed. Then on reaction tank number 2 we add caustic or acid depending on the pH. pH is critical here to try and keep everything pH neutral, between 6 and 8. Those can be stored within the container or outside depending on volumetrics is being processed. This system here we've got is an 8 cubic hour unit. On the bottom of the chemical pumps we've got what they call a footer valve. This is basically simply takes suction from the IBC or the drum through into the reaction tanks. On here we've got a compressor. The compressor is a key part of the process. It's basically adding air into the saturation vessel, which is here. So we have the compressor here, we have the saturation vessel here, and we have the recycle pump here. What this does is this is taking recovered water, clean water, and injecting it into the saturation vessel with addition of air. The easiest way to explain this is basically by taking a can of soda, shaking it, opening it, you've got aeration within the vessel. It injects air into the vessel so it basically floats out the dirty contaminants. Inside, on top of the vessel, there's a scraper assembly which takes the contaminants off into a sludge pocket and transferred away. And during some of these contaminants, you can use this, some of the farmers for example in the distillery market use the sludge to spray in the fields. The clean water can be repurposed. As I said, we are repurposing the water here for the process initially, but the clean water can be used for CIP operations, for irrigation, lots of different purposes. Okay, so the benefits of this system, by cleaning up the water, means that you've got no haul-off costs, which again it means you've got less carbon, reduce the carbon footprint, less emissions. Repurposing, as I said, is good for the environment because it can be used for irrigation, for cleaning purposes, or for actually going through the process again. So this particular system here, the 8 cubic hour unit, runs on very low power requirements. 32 amp power supply, 3-phase, is adequate to run this whole system, which is very low power considering the other technologies that's in the marketplace for cleaning up water. It's fully automated, periodic checks to be done to check the equipment, do the PMs in the system, and the thing will run forever.